Imagine a surgeon carefully removing a section of plaque from a patient's carotid artery. This is a routine procedure to prevent a stroke. The material removed is a waxy, yellowish substance, a mix of cholesterol, fats, and calcium. But when researchers placed this specific plaque under an electron microscope, they found something that doesn't belong. Sharp, geometric shapes stood out against a biological landscape. These were fragments of polyethylene, the same material used in plastic bags and bottles, alongside particles of polyvinyl chloride, or PVC. For the first time, we had visual confirmation of synthetic polymers lodged within the very structures that can fail and cause a heart attack or stroke. How does a piece of a water bottle end up in an artery next to your brain? The journey begins with the sheer scale of our plastic world. Every year, we produce over 400 million tons of plastic, and it breaks down, but it never truly disappears. It becomes microscopic dust. You inhale it from the air, where synthetic fibers from clothing float unseen. You ingest it from water bottled in plastic, and from food that has been stored in plastic containers or contaminated through the food chain. These particles are smaller than the width of a human hair. Many are nanometers in scale, small enough to behave in very strange ways once inside you. Your body has walls, barriers designed to keep the outside world out. The most important of these are the lining of your intestines and your lungs. Think of the intestinal wall not as a solid barrier, but as a complex, selective filter with specialized cells. Normally, it allows nutrients to pass while blocking pathogens. But particles below a certain size, especially nanoplastics, can slip through these defenses. This process, called translocation, allows them to pass directly into the bloodstream. They can also be engulfed by immune cells, which, in a case of mistaken identity, carry the plastic invaders across the barrier like a Trojan horse. Once in the bloodstream, the plastic is no longer an environmental contaminant. It is now a component of you. It travels the 60,000-mile highway of your circulatory system, carried along with red blood cells, oxygen, and nutrients. These particles are jagged and foreign. They are not soft and pliable like your cells. They tumble through vessels, scraping against the delicate inner lining called the endothelium. Some will be filtered out by the liver or spleen, but many continue to circulate, eventually embedding themselves in other tissues. They accumulate in areas where blood flow might be turbulent or slow, such as the sites where atherosclerotic plaques are already beginning to form. Your immune system is built to handle biological threats, but it has no evolutionary playbook for dealing with PVC. When immune cells encounter these plastic fragments lodged in arterial plaque, they recognize them as foreign invaders. They initiate an inflammatory response, releasing chemical signals called cytokines to call for reinforcements. But because the plastic cannot be broken down or digested, the alarm never turns off. This creates a state of chronic, low-grade inflammation directly at the site of the plaque. It's like having a splinter you can never remove, constantly irritating the surrounding tissue, but deep inside a critical artery. This chronic inflammation has a devastating effect. It destabilizes the plaque. A stable plaque has a thick, fibrous cap holding its soft, fatty core in place. Inflammation weakens this cap, making it thin and fragile, like worn-out fabric stretched too tight. The presence of the jagged plastic particles may also act as physical stress points. The study that found these particles also found that patients who had them were more than twice as likely to suffer a heart attack, stroke, or death. The plastic turns a chronic condition into an acute crisis, dramatically increasing the odds that the plaque will rupture. When a plaque ruptures, the body's response is to form a blood clot to seal the injury. But inside a narrow coronary artery, that clot can block the flow of blood entirely. This is a heart attack. The discovery of plastic inside these plaques doesn't just add a new ingredient to a known problem. It fundamentally changes the nature of the risk. And it raises deeper questions. What other effects are these materials having? What about the chemical additives, the phthalates and bisphenols that leach from them over time? We are all, unwillingly, part of a global, uncontrolled experiment. The plastic isn't just in the ocean anymore. It's in our blood, and it's in our hearts.
Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.